I'm Miriah Peterson. My day job, I work for MX. One of my night jobs, Soy Pete Tech, where I create content, all that fun stuff. Today we're going to be talking about data reliability engineering. So, do you have reliable data? I'm going to put up some things on the slide, and if you have experienced it before, just shoot a quick hand in the air. I can't see them, the lights are too bright, but we can all, experience mutual pain. Have you ever had a broken dashboard? Missing data views? An Airflow job that didn't run? That's why we all love Airflow, right? Missing data in a table. Nobody's had missing data. Duplicate data. An API that was broken or uncallable. Or maybe an ML training job failed. Guess what, guys? That's not reliable data right there. Data downtime is a time that basically is anything that happened on that previous slide. It is in software, when you say downtime, basically it means unavailable. This is a little bit different because it's not just, it's unavailable. It could be incorrect, it could be missing, or it could just be inaccurate, right? It's leading to conclusions that are inaccurate as opposed to be fundamentally wrong, like, wrong algorithms type of thing. So what happens is when data is down. I was going to have you shout them out at me. So if you're loud, feel free to shout. What happens when your data is down? If not, I have ideas.
Lots of different things.
Everything. That was everything happens. Other thoughts? Oh, that's what I really like. SVP slacks you. Those executives really like it when their numbers are crisp. Other thought? You lose money, that's a good one, yes. So out-of-date dashboards, that's when the SVPs say, I need to go take this to the board, and you're like, what? Why didn't you tell me 3 weeks ago? Your ML trainings are broken, you can't hit your deliverables. Anybody else have billing running out of their warehouse and they can't get people to pay them? Well, billing runs out of my warehouse, and they get mad every time they can't charge their customers. So, basically there's a broad range of business side effects that happen because of our data being down or erroneous. Nothing major. This is my favorite book. First data engineering book I ever read. Very first chapter, it goes into a very fundamental topic that then gets ignored in the other 16 chapters, and that is every service we build needs to be reliable, maintainable, and operable. So when we're building any system, especially as this book talks about data-intensive systems, we need to answer these questions. Will our system be reliable, be maintainable, and operable? And hopefully, we can continue to address that going forward. But a thing about reliability is that reliability does not mean it is unbreakable. It is not a perfect system. Reliability is not building an unbreakable system, because unbreakable systems are the fragile systems that we pray never breaks because the person that built it retired 20 years ago. We need systems that if they fail, we can resolve it quickly without any impact, as opposed to systems that never break. That is what a reliable system is. So let's talk about minimizing data downtime and building those reliable systems. Anybody seen this picture before? This picture comes from the Fundamentals of Data Engineering book by Joe Reese and Matt Housley. Where in this life cycle can data go down? It can go down at generation. It can go down at the point where we're giving it to our stakeholders. It can go, before machine learning, it can go down before we throw it over to BI. It could go down when we're running a transformation. It can go down when we're trying to pull it from the data store, the database. It can go down when we're sending it to our reverse ETL engine. The database itself could, not database, but the data store itself could have issues. So literally anywhere we could have an instance of data downtime. But good news is we have tools for managing it, and these are those undercurrents, right? We have good software engineering practices. We can implement tools, leverage tools, build our own tools that make this system easier to react to, easier to manage, easier to monitor. We have orchestration tools. We have data ops tools. We have security tools. All of these tools will help us build a more reliable system. These tools combined are data reliability engineering. So let's go into data reliability engineering. First time I heard about this was on a fabulous podcast, data engineering podcast. Igor Groznov, who is the founder of Big Eye, was talking about what he sees data engineering, reliability engineering to be. He says it's a natural extension of data engineering. It says it's thinking of data problems like an engineer and using software or I don't want to say dataware, but engineering better solutions for that problem. So, where do we start? Anybody remember the 5 V's? Is it taking anybody back a little bit, thinking about those 5 V's? I still like them. They're pretty good. Let's conceptualize a little bit. Can we quantify these? Are these things we can measure to describe if our system itself is reliable? Do you know how much data is flowing through your streams or APIs? Do you know how much data you're processing or exposing? Do you know what that should be? Do you know how much data is being added to the warehouse regularly? Do you know if that is an anomalous spike or not, right? Have you ever had somebody sending too many records because they're all duplicates? Is that something we expect? Are all of the sources serving data? Are we getting, or if you have things coming from a bunch of different software services, are they all coming in? Are your third-party data sources coming in? Are the insights, veracity is my favorite, are the insights in line with expected behavior? Does anybody ever go check out and see if any of the analytics dashboards look like how they're supposed to look? Is all of the data being used? How much data is sitting around and not being used at all versus what data sets are being accessed regularly or all the time? And with what frequency? The ones that are accessed all the time and with the most frequency, they may have the most value, or they're just maybe a service that's broken and is calling them too much. And again, we do care about throughput of data because it can help us understand if something is what we expect or what we not expect. Looking for patterns as well as anomalies in our patterns can help us build reliable systems, right? You don't ever want to have too many things calling your data warehouse and locking it, or getting rate limited at the API layer. You want to make sure everything, those kinds of anomalies are things we need to track and be aware of. When I think of metrics, observability, right? We're trying to understand. Metrics usually are the first line. So we have the idea of things we want to measure. Then how can we use metrics to measure them? If you go to the SRE handbook by Google, they have 4 basic pillars: latency, traffic, errors, and saturation. These are things that are, generally speaking, available out of the box, no matter what you're using. If you're on the cloud, every single cloud service provides these through a monitoring tool. If you're on-prem and you're using any database, there's a plugin for it. Like you're using New Relic, you're using Datadog, you use Prometheus, you use whatever monitoring tool you have, you will get latency, throughput, saturation, all of that metrics for your data warehouse. You'll get error notifications. And so can you set these up to understand what's going on? If you were running on Linux, a Linux OS system, OS metrics are built exactly to help you understand this. These basic 4-level metrics are perfect for understanding when things go wrong. So if you can answer these at any point in time, what is the next thing you should do with that? Metrics are the foundation of data observability. But what we need to do is we need to take them and translate into something that matters for our stakeholders, right? Like we could be hit with metrics all day long, but if they don't mean anything, then that's just noise. And what happens when we get too much unimportant noise? We just cancel it out and quit listening. So we need to make sure that any noise we hear, alerting, metrics, whatever, is valuable and important. And what to do that is we need to understand what matters to our stakeholders. We do this by setting service level agreements. We'll run through just a quick exercise of an example of how to do it. This is not a real life example, it's just a generic example. So we have an SLA. So imagine I have a business analytics team and they want to have near real-time data of what happened at least yesterday, right? So we have a minimum freshness of 24 hours. That is our agreement that we've established between my team and that business analytics team. Okay, great. Now I'm going to set up service level objectives to capture what I need to put in place so that I never break that agreement. Okay, let's go ahead and say we will have pipelines that extract the data from source, transform them, and performs generic analysis once a day so that those dashboards run. We'll make sure that if it breaks, we get an alert or an error reported to us, and we can re-trigger within that 24 hours so that we never break that SLA. And what we do is we then set up indicators that let us know when those objectives cannot be met. So we say, oh great, an error was reported. Maybe I threw it in a Slack channel. Maybe I had it ping me through a reporting service, right? Or a timeout was reported. Oh, this took too long. It canceled after 10 minutes. I love context timeouts on APIs or database calls. If it takes too long, I should know so I can go re-trigger it and figure out what's wrong. And then do these alerts let me know if what needs to be happened? Does it mean I need to manually rerun this? Usually, yes. Ideally, we'll be able to fix it so it automatically runs in the future, but I need to hit my SLA, so I'm going to manually rerun it and then look for fixing the automation in the future. SLAs are only as good as the end user. I hope you like these pictures. AI generates great things for us who need to make slides. As we scale data orgs, right? Small data orgs usually only have a couple of people. Bigger orgs have a lot of different stakeholders that now care what you want. And each person, each end user is going to have a different expectation. I know that business executives, biz ops people, if you're like me, billing teams, they probably only care about it once a month, once every 6 months. We just need to make sure that whatever our agreement is, it's in by that specific day they want. Data scientists, they usually like everything and they like it as reasonably up to date as they can be. They're a good use case for that 24-hour freshness or maybe 1 week freshness. And then, I don't know if you're like me and have seen an uptick in chatbots or other tools that now have AI directly in the software, that's going to be your ML end user. If you have any kind of live ML training, you're going to want those things to be up to date and running realistically. They're using your data to train, they're using your data to update, and they're using your data to understand what the customer's doing. Those are probably, anytime an ML stack is integrated into a production software service or production software service is pulling in from a warehouse or a data store, those are going to have the highest uptime requirements or the smallest downtime requirements. So they're probably going to be, how real time can I get? I don't want to say this is a 5-9 situation, but users are kind of okay if it takes them 5 minutes to get something to work, but if it takes longer than 5 minutes, then they're going on Twitter and tweeting at your company saying it's broken. So figuring out what the need of each persona is, and then understanding what data that persona needs can help us define what the minimal downtime requirement is acceptable for different parts of our system and help us better understand the needs of intervention. Is this something that I need to handle right now immediately? Is this something I need to handle today? Or is this maybe something I can handle next week? So this is not all downtime is an outage. Like I said, in software engineering, usually something goes down, it's an immediate resolution time because somebody somewhere is using it. That's not always the case. Sometimes it is. Sometimes we need to jump on it and fix it right now. But it doesn't always need to be addressed immediately. Usually, SRE teams have this concept of an error budget. They will allocate a certain amount of hours to a sprint time and say these amount of hours is dedicated to fixing non-emergent problems. They're used for fixing bugs, debugging, doing tasks for tech debt. I think we can take this and throw this right into our data engineering stuff and say, hey, we had an alert that fired, this thing didn't run, I could manually rerun it today, but I need to fix that automation. I think this is something, since it will be rerun again tomorrow, I need to put today, great, I have 4 hours in my error budget, I can use that 4 hours on this. If you don't have 4 hours on that error budget, say, great, I'm going to make this highest priority on my next sprint or on our next goal, first thing I'm taking, but until then, I'm gonna make a reminder to go in and manually rerun that every day. So it's about making sure that you can keep the expectations of the end user while still making sure that your management is manageable. You're not constantly being pinged and you're not constantly fighting fires, but is it, and understanding when it can be taken care of. So, did I really go that fast? I'm talking fast. So, what is a data reliability engineer? So, at what point do you need somebody that sits there and specializes in data reliability engineering? If you're a small company, don't even worry about it. Everybody's wearing every hat. But I would say if you're starting to do any of these things, are you building tools that enable a practitioner, right? Are you building data infrastructure tools to enable data science? Are you building tools that let pipelines run automatically? Are you building tools to maybe make ML or data science easier? Are you trying to automate your infrastructure setup? Are you trying to hyperscale on Kubernetes, do all those things? Are you creating platforms for machine learning? You doing any ML ops? Are you regularly interfacing with cloud infrastructure or operations? Or are you just struggling with downtime? In any of these situations, it's good to have somebody that dedicates all or part of their brain space to solving these specific problems, because it can end up costing the business. And that's what I think a data reliability engineer can be a good specialization. I've been calling myself a data reliability engineer for a few years now. I talked to Igor right after he did that podcast, because I was like, hey, we just formed a data reliability engineering team at my company. And he said, what? Nobody does that. So I see the data reliability engineer as somebody who's taking a lot of the tools that are helping software, SRE, infrastructure, they're bringing that over to the data space. They're making it so that we don't have the steep cavern between the uptime and software and the uptime and data reliability, and we're making things work together. They're working on things like data contracts in the data stack, making sure that they're not broken so that things the software engineers do not break what the data engineers are doing. They build trust. They're working with cloud infrastructure teams to set up the right automation, and they're looking for places in the data systems where they can add monitoring and metrics to better inform their team of things that need to be remediated so that they can better work together. I do see data reliability as kind of a cross-functional role, which means it is one person who would work with who is specializing in a team of other data engineers or infrastructure engineers. I don't know if I would ever say, oh, we have an entire data reliability engineering team, even though I did that before, because I do think collaboration matters and stuff like that matters. So, in conclusion, I talked really fast. So when I practiced this, it took 10 minutes longer. We all experience downtime. Everybody does. We all raised our hands. Data reliability engineering is a set of tools and practices that can help remedy that. In a large organization, more important metrics and quantization are very important to understanding what our reliability needs are. Once we figured out what those needs are, we create SLAs for the end user. And what's most important is we create the appropriate amount of urgency for when things go wrong. We don't want to make everything doesn't need to be an alert, because that's just more noise. We need to make sure that we get the right amount of information at the appropriate time to make sure we handle our agreements and can keep our stakeholders happy. And that is the end of this.